My name is Jen Lewin, and I'm an interactive light artist. I create interactive sound and LED art that can be the scale of a landscape. Humans across the planet love light, and we immediately get interacting with light. And so I can create a light interaction piece, and everyone participates and plays with it and understands it. My largest piece is called Cosmos. It's over 15,000 square feet and had 240,000 LEDs. My work has been shown in over 18 countries. I think the pool has been to over 15 countries and hundreds of exhibitions. The very first pool was actually an honorarium grant from Burning Man in 2008. I built it, I had to bring it back and rebuild it. And in fact, I think the pool's been fully re-engineered and rebuilt probably over 10 times at this point. There was a lot of learning in creating a work like that. And as I got better at building the work and better at implementing my vision, then the work became more mobile and was able to travel around the world. There's been something really magical about being on the team, moving the pool around, and seeing how in all of these really different places, everyone jumps in and plays. And when you kind of get down to the core behavior of humans in play, everyone plays the same way. Kids immediately get it, adults hesitate a little bit more. Everyone takes photos. But in the end, you sort of see this really amazing connectiveness between all of us, which is what the sculpture's about too. So to have the sculpture be about that and then to have it move around the world and to really see that has been special. In the beginning phase of any project, there's a long period of time where I just let ideas percolate. So I'll spend a lot of time actually flying through the site and analyzing the site in 3D. Kind of step one is being able to understand the space. At that point, then I come up with an idea, and then I don't actually sketch it on paper, I render it in 3D. Once we have a three-dimensional model, I sit down with my team and we start to figure out how to build it. It could be up to a 2-year inventive process of figuring it out, because it's almost never straightforward. How are we going to make it? What can we do? And so there's this amazing process of iteration and invention. We're building new circuit boards, we're trying to figure out what the software will be, we're writing software, we're testing things. So there's just constant experimentation. Finally, we come up with a prototype. We all approve of the prototype, and then we go into fabrication. And in most of my works, that means you take the prototype and you make 1,000 of them. So there's a lot of fabrication, there's a lot of repetition. We assemble everything here in the studio. And then there's a testing phase where you have to test everything, methodical testing of every component, testing all the LEDs, you have final assembly, and then eventually you go to the site and you bring it all together. And I think that's the interesting thing about my process. It's really looking at all of the pieces and then figuring out how you can bring them all together. It's not just one or the other. So it's both the material, how the material is going to work with the circuit board, and then how the lighting is going to work within that. I love it. I think my favorite days are actually my software days where I get to sit and write code all day. I loved computers and programming from a very early age. I was part of an experimental program, a really awesome experimental program called Logo, where I learned to program in 3rd grade. But I was from a little bit of an earlier generation where you were supposed to pick. It was left brain or right brain. So you were supposed to be an artist or you were supposed to be an engineer. And I rather stubbornly refused to do that and just decided I was going to do both. This is actually all of the custom software that's running the Aurora sculpture in Minneapolis. And I'm looking at video that I've created and composed, and it's actually being mapped to an LED array that then is physically in the space. This is interesting software because it's also pulling in weather data. It's looking at live weather, and based on weather, it's like creating all these different playlists. So if there's a weather condition of rain, it will actually play a rain video. What you're looking at here on this screen is actually another piece of software that we built internally that allows us to communicate with any of our projects. And I'm actually communicating with an XP radio. That's an XP radio. And I can, for example, set all sorts of parameters. So I have this curtain downstairs. And if I wanted to, I can actually trigger a stored palette. I'm looking at a blue palette here, but I could actually compose a new palette right now that would then get stored onto the work permanently. So if I left, then the work would actually display that and use that as sort of a future color. So I'm really creating like a skeleton structure for all of these different kinds of lighting conditions. And then I'm creating an interactive seed, and then I'm allowing people to play within those conditions. Ground-based pieces are really unusual and different compared to most pieces like this. There's no single master computer in the Pool or Aqueous or Cosmos or any of my ground-based pieces. Many years ago, I made a decision to build these pieces as mesh networks, and that was actually an unusual decision at the time. Now it's much more common because we have all these smart devices in our home. Early 2000s, that was not common. Each platform is smart. It has all of this intelligence. It knows you're standing on it. It can animate, and then all of the platforms communicate with each other. From a code perspective, it can be really interesting because you actually are very constrained in what you can do, but you have to build this sort of very organic system that is meshable, that allows for this dynamic mesh network to be created. So these are some of the components that were used in the Aurora, which is a recent sculpture we installed in Minneapolis. You're just looking at some of the prototyping. We had to prototype in an aluminum ring form, so you can see one here that I've actually glued together to prototype. The final Aurora is built out of a welded aluminum form, and this is just a model of one hanging up here. But in the Aurora are thousands of glass bulbs, so it's actually what looks like a traditional glass bulb. It's just not wired, so it doesn't have any kind of incandescent wiring in it. And then we had this piece made. This is a custom acrylic piece that actually was injection molded. And then we built and designed these really cool LED rings, and they have a custom injection molded piece on it and 3 LEDs. The system is really interesting because basically you can attach a glass bulb and then you can screw on the LED on the back. And then all of these LEDs can chain together, creating thousands of them, but still creating this sort of transparent twinkle. If you look at it, you can sort of see through it. And clearly this is just a prototype, so the difference with this prototype is our boards in the back are actually black, and I didn't want that opacity. I wanted them to be semi-transparent. So if you look at the ones that we actually made, they have this really beautiful, more semi-transparent glow to them. So just examples of a large art piece that requires many, many different components. To me, there's something so intrinsically interesting about this element of participation, bringing people into the work and allowing them to create this relationship with the work where it's the work and them. All of the work has that piece of it at its heart, that idea of being part of something and being able to create that connection within public art. There really aren't that many moments where we get to play music together collaboratively. The harps are really designed with sounds that allow you to run around, play, and actually have this music experience without necessarily knowing how to play music. So it really becomes a participatory experience in light and see this really beautiful light effect on their hands. This is the guts of one of my newer laser harps. We have it out here, we're prototyping it. This harp is using a custom sensor. What this is doing is actually sending out an infrared beam, and it's triangulating that beam off of my hand and sending back both distance information as well as sort of the speed of change. So all of that information is being sent, I'm actually triggering it right now, it's being sent back to a custom controller that's a little bit away from us. It's not as simple as just a single note, and you'll hear on several of the notes that the notes change over time and that there's like a grace and a breathiness to the notes, so that you're not just triggering a single note, you feel like you want to move through the notes and play them. All of my work has an Easter egg in it, which means there's some sort of component that if you trigger and find will affect other components. In the case of my laser harps, there is a laser which we call the magic laser, and if you trigger that laser, you'll change the sound. So right now you can hear these kind of smooth and ethereal sounds, but if I hold this particular laser, I know which one it is. I've changed the sounds. So by holding it for that extended period of time, the sounds have changed. In my ground-based pieces, there's usually a magical platform that when you stand on will change the entire color palette for the rest of the sculpture. This is going actually to a playground. I build what are called magical harps for the Magical Bridge Foundation, which creates accessible playgrounds. So it goes into a playground that's really meant to inspire kids of all ability to be able to play and create music. The hardest aspect to learn of all of my work has been the hardware. There's so much of building hardware that just comes from a lifetime of building hardware, and I'm going to be learning forever. Over time, the tools have become so much more sophisticated. So our circuit boards have shrank in size. Almost everyone who starts building hardware starts in breadboards. This is a breadboard example of the second laser harp I ever made. And it's programmed with a PIC microcontroller. Looks like the microcontroller actually popped out. In the end, it only took me a few days to assemble. It took me months to figure out and learn how to make. I was just learning electronics, and so I actually had to really figure out how everything was going to work. I had to do all the math and computation to understand how the circuit was actually going to function. Things change. This is one of the OG prototypes for one of the first pool sculptures. I like to keep it around. Very scary looking for me. But this is one of the internal pieces. All of this was hand built. Hundreds and hundreds of hours of actually soldering because we made hundreds of these, all handmade. And then, of course, something like this has become much more elegant. I don't have components on this, but much smaller, more elegant boards. And actually, everything you see here, plus probably 10 times as much is done now on this board, which looks much cleaner. So this is indicative of either my temporary or permanent work. We have a custom circuit board that's a wireless networkable component. There's obviously a power supply. Right now we're testing everything and making sure that it's ready. We're burning in our LEDs and keeping them running for several weeks. Once we know that this is a go, we'll then go through the process of waterproofing it. We experimented a lot with coatings. We've used a lot of different kinds of coatings. Now we actually pot all of our electronics, which essentially means we fully encase them in a particular type of resin. So they're bricked, per se, in resin. And then we test them by actually sitting them in water or soaking them in water for days. We've actually had tests where we've had pieces submerged for a week and then heating up the water and cooling the water and dealing with temperature changes that might also affect something that's wet. It's no small feat to make a sculpture with hundreds of electronics that you jump on, and a sculpture that can be rained on and snowed on and deal with really, very interactive behavior. The first time I saw people interact with my work, I had this sort of surprised moment because up to that point I'd been so caught up and so focused on the technology and making the technology work that I really hadn't stepped back to sort of see how joyful the piece could be. I wanted something integrated. I wanted something kids liked and grandparents liked and different cultures liked. I feel inclined to want that and desire that, and I want to see pieces in community that truly engage with community, and community is diverse. To create public art and to create these places and to affect space requires, or I think it requires, having the desire to bring everyone together. To me, public art at its best can really create a sense of place. And a sense of place is really important. It's how a community aligns with where they live. It brings in other people and it really connects those living in a place with where they are. I hope that young people play with technology more, and I want to see more artists working within this medium. Artists making dynamic, connected, high-tech, beautiful artwork.